This is a quick video on section 2.1 and 2.5 and 10.1 related to inverse functions and composition. Okay. We know how to compose two functions. We've seen that in the previous video and in the lecture class where we would look at, for example, f composed with g of x, or g composed of f of x, something like this. We've seen composition there. So let me start with the idea of an inverse function with a pretty straightforward example. This is an example we revisited several times now, that we have a formula that takes the chirp rate of some crickets and uses it to predict the temperature that is outside. So for example, that if we have the temperature, if we have the chirp rate, we can predict the temperature, right? Temperature of 1, the temperature is going to be 40.25. If the chirp rate is 4, we're going to have a temperature of 41 degrees, right? So this is what this function predicts. Okay. If you take this formula and you solve it for the variable r instead. When you solve for r, you'll get t minus 40 is equal to 1/4 r. Multiply both sides by 4 to get t minus 40 is equal to r. And now if we turn this around, we now have a formula for the chirp rate, which is a function g of the temperature. Okay. So now we can use this formula, this second formula, to take a temperature and use it to predict what the chirp rate of these insects is going to be. So for example, if the temperature is 50 degrees, then 4 times 50 minus 40, that would be 10. 4 times 10 is 40. So at a temperature of 50 degrees, the chirp rate is going to be 40 chirps per second probably, or something like that. Okay. Now these two formulas, there's a relationship between them. There's a relationship between t is equal to f of r is 1/4 r plus 40, and there is a relationship between that and the function r is equal to g of t is equal to 4 times t minus 40. There's a relationship between these two. So let's look at a couple tables of values here. Okay. If we say, for example, choose a chirp rate, okay, use the temperature function f of r, okay, and then at a chirp rate of say 4, right? We decided that the temperature was 41 degrees. But if you then take this temperature of 41 degrees and use it with the chirp rate formula, where the temperature predicts the chirp rate, what you will have is 4 times the temperature is 41 minus 40. You will get 4 degrees. Okay. So for chirp rate. So if you start with a chirp rate of 4, use the output function given by the function f of r, then take that 41 degree number and put it into the other function, that you get the same number out that you started with. Okay, this is characteristic of what are called inverse functions. So for example, if the chirp rate is 16, that the temperature then would be 1/4 times 16 plus 40. That would be 44. Take that 44 and plug it into the chirp rate predictor function, which is 4 times 44 minus 40, to get 4 times 4, which is 16. And you get the 16 back again that you started. So this idea that taking g and feeding into it the function f of r, that whatever r you start with, like 4 or 16, you will get, after composition of functions, the value r back again. So that's step one, to show that two functions, f and g, are inverse functions of each other. You must show that the composition g composed with f of r is equal to r. The second thing you would need to do is to then start with, instead of r, start with the temperature. And then use the formula r is equal to g of t. And then you can then take the chirp rate r and then use the function t is equal to f of r. So for example, if the temperature is 10, okay, that 4 times, hold on a second, is that t plus 40? Oh, if the temperature is above, let's say the temperature is 50 degrees, I'm sorry, then 50 minus 40 would be 4 times 10, which would be 40, a chirp rate of 40, and then take the temperature function, okay, with the chirp rate of 40, so that'd be 1/4 times 40 plus 40, and that would give 10 plus 40 is 50. Okay. So again, you take a temperature in, find the chirp rate, and then use the other function for the chirp rate to go back to temperature, and you get the same temperature that you started with. Okay. So what we have found here is that the function f composed with g of t is equal to the t, the starting temperature that you picked. Okay. This behavior is indicative of inverse functions. Okay. So what we can say here is that the functions f and g, are inverse functions of each other. Okay. If we're assuming that t, the function called f, is the formula that predicts the temperature from the chirp rate, then if we know that functions are inverses, they satisfy these two formulas right here, then what we'll say is that the formula r, okay, which was a function of t, we'll call that f with this little -1. This denotes that r is the inverse function of f. Okay. Another example of the way this problem can show up. Okay. Let's take a look here. Okay, let's take a look at this example. That we have y is equal to f of x is equal to 2x plus 8. This is given. Okay, so y is given as a function of x. If you solve for the variable x, then x will be y minus 8 divided by 2. So now we have a formula g of y. Okay, and it's x is equal to g of y. Let's show that this function, that f of x is equal to 2x plus 8, and show that the function g of y, which is y minus 8 over 2, let's show that they're inverses. Show that these two functions are inverses. Okay. The first thing that you need to show is that f composed with g of y, is that in fact equal to y? Well, we need to take the function, and into the function f, we need to substitute the function that we just found, g of y. That's a 2. But the function f was 2 times something plus 8. It's the y minus 8 that gets substituted in for the x, so the 2's cancel, y minus 8 plus 8 is equal to y. So we do in fact get that f composed with g of y is y. The second thing you need to show is that g composed with f of x is that in fact equal to x. F of x was equal to 2x plus 8, but the function g says that we have y minus 8 over 2, but what's playing the role of the y is 2x plus 8. The 8's cancel, and then the 2's cancel, so g composed with f of x is x. Okay. And it's those two properties that go together to show that the function f, y equal f of x, which is 2x plus 8, has an inverse function called x equal to f inverse of y is y minus 8 over 2. So instead of calling the function g, once you know it's the inverse function, you can denote it with f with this little superscript minus 1. Okay. One last way that these problems can appear to you, okay, is that you can be given, for example, some function values. You can be given one value of the function of g, and you can be given the one value of the inverse function, and from there you should be able to find what are some other values of both functions. Okay. So for example, if g of 10 is equal to negative 26, you know that g inverse of 26 with a negative sign has to be 10, because you know that g has an inverse. Okay. So you know that g inverse of g of 10, you know that that has to be equal to 10. And the only way that's going to work is because g of 10 is equal to negative 26. So to get 10 back again, g inverse of negative 26 has to be equal to 10. Okay. The same holds for g inverse of 0 equaling 7. This will imply that g of 7 has to be equal to 0, because you know that g of g inverse of 0 has to be equal to 0. So to get that to happen, you know that g inverse of 0 has to be equal to 7, because g of 7 was equal to 0. So we knew that our g of 7 value had to be correct of 0, because g and g inverse are inverses and therefore have to have this composition of functions being true. So that is a good start and an introduction to a variety of inverse function examples.